Okay, class. So today we're going to be looking at chapter 15. As you can see, chapter 15 is labeled the system of equations. And just to kind of review a little bit, we're going to be revisiting the linear equation format. If you recall, that's the type of equation that's the y equals mx plus b. Let me get my marker to work. Y equals mx plus b. If you recall, the y and the x are going to be through an ordered pair that's going to be provided. The m is the slope or the steepness or the inclination of the line itself, and then b, it's the y-intercept. So what I'll do is I'll write it down right here. Sorry for the cluttering. M equals slope and b is equal to the y-intercept. Okay, so again, y-intercept is labeled as the letter b. Let me erase this here on the top because it makes it look like a b here. There you go. So the y-intercept is the b, the m is the slope, and we're going to be revisiting the format of a linear equation as y equals mx plus b. So in section 15.1, we have a little bit of a description of what a solution in a system of equations. A system of equations is pretty much a set of equations. It has to be more than two. There is there is no limit as to how many equations could be in a system. However, for the sake of this chapter and for the sake of this class, we're going to be focusing mainly with two equations. And the definition here I have of a solution in a system of two variables is that it provides an ordered pair that makes both equations true. So just to review, let's go ahead and look at an example of how what it is to find a solution of a particular linear equation or an equation that could also be added or contributed to a system of equations. So it's a straightforward substitution of values. With the first example here again is you're going to find the solution for the equation y equals 2x plus 1 when the value of x is -2, -1, 0, let me erase that here, 1, and 2. So again, if you recall from the linear equation section that the reason why I asked you guys to choose at least two negatives, the 0 and the positive, that's so that we can see how the trend or which path this equation would cover when you are going to be graphing it. So again, it's just a straightforward substitution. So I'll put y equals y equals 2, and then I put in parentheses the value that we're assigning for this particular example as -2. So we have 2 times -2 gives you -4, plus 1 will give you -3. So for the value of -2 as x, the y corresponds to -3. So I'll just go ahead and write it as an ordered pair. So remember that the ordered pair is it's the x first and then the y. So in this case it would be -2, -3. Okay, that's going to be our first order pair. For the value of x equals -1, it's y equals 2 times -1 plus 1 is equal to what, right? Now, don't be tempted. -1 plus 1 cancels out to 0, and you're left with 2 times 0 is 0. No, that's not the case. Remember, we have to multiply first and then continue up with according to the order of operations. So here we have 2 times -1 is -2 plus 1 gives us -1. So our order pair, it's -1, -1. The next one would be at 0. So y equals 2 times 0 plus 1, which is pretty much 2 times 0 plus 1 is just 1. So our order pair here would be 0, 1. Then the third one would be y equals 2 times 1 plus 1, which is 2 times 1 is 2, plus 1 is 3. So it would be 2 and 3. And the last possible example that we need to substitute the value for is positive 2. So it's 2 times positive 2 plus 1 gives us 5. So here the order pair is 2, 5. So what does that mean? The order pairs negative 2 and negative 3, negative 1 and negative 1, 0, negative 1, 2, negative 3, and 2, 5. What that means is that these points, remember that these are order pairs, are going to be points once they get plotted in an XY system or what is it, the Descartes system of graphing. Once you plot those points, they will make a straight line, and thus these points, since they lie in the graph of this equation, they are solutions for this particular equation. So that's just only one equation. Now, if we look at the solution, the definition that I gave you here, it says a solution in a system of two variables provides an ordered pair that makes both equations true. So we're going to see if, or we're going to determine if the point order pair 2, 3 is a solution for these two equations that are part of a linear system of equations. Okay, so again, we just substitute. Keep in mind again that the first number is the x and the second number in the order pair is the y. So we just do a straight substitution. So we put here 2, oops, is equal, let me make sure I have the right example. Okay, sorry guys, I had put positive 3 here. It's actually 2, negative 3. So I copied my from my notes a little bit incorrect, but now it's the correct problem. So now we have 2 times negative 3 plus 8. So we're gonna do the work out the problem. So on the left hand side of the equal sign we have 2, and then 2 times negative 3 gives us negative 6 plus 8. Positive 8 take away 6, it gives you 2, right? So that means that if the left side of the equal sign is equal to the right side of the equal sign, that ordered pair here is a solution to this equation x equals 2y plus 8. So that's one solution that we found, right? So let's put a little check mark here that it does work. So now let's substitute it into the second equation that is part of the system of equations here. So again, we do a straightforward substitution of values, and wherever we see the x, we're going to plug in the number 2. So we have 2 times positive 2 plus negative 3 equals 1. Okay, I'm just copying the number, so don't be confused as to why I have a plus and a minus here. Okay, remember the x is the 2, the y is the negative 3. That's the reason why. So now look, we proceed with the completing the mathematical process here. Is 2 times 2 gives us 4, and then positive times a negative gives us a negative, so it's minus 3 equals a 1. So 4 minus 3 gives you 1, so 1 equals 1. And that is also true, right? So this point, positive 2, negative 3, is also a solution for this equation here. So given that both equations have this point in common as a solution, the solution to the system of equation of 2, negative 3, it's true. So what does that mean in English, let's say? If you were to graph the equation of x equals 2y plus 8 and also the equation of 2x plus y equals 1, they would actually intersect, or they would cross at the point 2, negative 3, and that's why it's considered a solution. At the point where any two linear equations meet, that's the point that's called a solution. Now, a linear equation, a system of linear equations will only have one solution. If it's going to be quadratic equations, such as in the case, I think we covered that in the previous, either previous section or the one before that, those equations, the quadratic equations, they could have two possible solutions, because remember the quadratic equations have x to the second power. So that 2 would give you the hint that it's going to have two solutions. Remember that in the linear equations it's only x to the 1, thus it only has one solution. Okay, so that's a little hint to remember. Okay, so one of the common methods in solving or finding a solution for a system of equations is called the substitution method. And just like it tells you, you're going to be substituting one of the unknowns into a second equation. This substitution method will work, of course, in systems of equations with two or more. That way, in order for you to find a value, one of the unknowns must be given. So they cannot just tell you, for example, find the value of this solution. Find the solution for that problem, right? Because it could have an infinite number of solutions. You cannot have two unknowns to find a solution. You always have to have the value of one unknown so that it can help you in finding the second value and thus finding the solution to that equation. Okay, so they will always give you a way to find that solution. So in this case, we have these two these two equations. The first one is x plus y equals 6, and the second one is x equals y plus 2. So the first thing that you're going to be doing is that of isolating one of the variables, one of the unknown variables. In this case, if you look at the second equation here, the x is already isolated. So that already makes it a heck of a lot easier in plugging it into the first equation. Okay, don't reinvent the wheel. If for practicality purposes, if you want to isolate the y here, you're more than welcome to do so. Remember that by you bringing this x to the opposite side of the equal sign, it would give you a negative x. So you would have y equals 6 minus x. If on the right side here you already have a positive x, a positive y, and a positive 2, mainly concerning the variables as positives, don't break your head and just use the easy parts that are already given to you. So what I'm going to do here, I'm going to be using the first equation, which is x plus y, and wherever I see the x, I'm going to substitute the value of y plus 2. So for x here, I'm going to put y plus 2. If you notice, I'm using purple to substitute the value of x that's given to us here in the first set of equations. So now what do? I will go ahead and I collect like terms, the y here and the y on this side. So that gives us 2y plus 2 equals 6, and we go ahead and proceed in solving for the algebraic way of isolating the value of y, so or solving for y pretty much. Okay, so we begin with the one number that's not the coefficient, so in this case it's the positive 2. We move it to the right side of the equal sign by subtracting 2 from both sides, so that cancels out the 2's on the left, and you're left with 2y equals 6 minus 2 gives you 4. And then again we continue with solving for y. Divide by 2, divide by 2, so we get y is equal to 2. Okay, so now here is our problem. Now we have the value of one of the variables, right? One of the variables is 2, y equals 2. So we can go back into the original system of equations and plug in wherever we see a y, we can plug in the 2. So then look, take a look right here, right? We have x is equal to y plus 2, and we said that y was equal to 2, correct? So we will have 2 plus 2, so your x is equal to 4. So we found the value of the x, and we also have the value of the y. So now we need to put it as an ordered pair. Our ordered pair would be 4 and positive 2. right? You put it in a parentheses, such as the way that you write order pairs. And this would be our solution for that system of equations of x plus y equals 6 and x equals y plus 2. So if you put, if for your answer, if you give me x equals 4 and y equals 2, yeah, you're right. Y equals 2 and x equals 4 is a solution, the components for the solution, but the answer, the best answer is in the form of an ordered pair, 4, 2. Okay, so that problem that I showed you previously was a straightforward problem as far as you were given one of the equations that showed or had a variable isolated. In this case here, you have values that are not isolated in both equations. So we're going to isolate for one of the variables in each equation, or actually we're going to look to see which equation can be isolated in a most simplest way. So if we look at the first one, we have x minus 2y equals 0. So let's try to solve for x and this one here. This is actually problem number 17 on section 15.2 of your chapter of the book. So for us to isolate x, we can just add 2y to both sides, and we have as x equals 2y. I didn't bring down the 0 because 2y plus 0 is just 2y, okay? So now, wherever we see the x in one of the original equations, whenever we see the x, we're going to substitute the value of 2y into the second equation. So we have 4 times 2y minus 3y equals negative 2, correct? We just substituted for x the 2y, correct, that we found here. So now we proceed with distributing that 4 into the parentheses. So it gives us 8y minus 3y equals negative 2. And we proceed in solving it, correct? So what is 8y minus 3y? Okay, that gives us 5y equals negative 2. Okay, so we have 5y equals negative 2. So we substitute, we continue solving and we divide both sides by 5. And here we have y equals negative 2 over 5. Let's go ahead and plug in this value of y to our rearrange format of the first equation. So we would have x is equal to 2 times negative 2 over 5. Remember that this 2 is a whole number, so it has a 1 on the bottom, right? When you multiply it, it's going to give you negative 4 over 5, okay? So there are going to be instances where you are going to be required to do fractions, and I think that for the sake of your homework assignments, none of them are going to be fractions. I want to keep you guys away from fractions because I know that some of you might not like them, and I want you to my whole point of this class is, one, to make sure that you understand the concept, and also two is to not shy away from understanding math and make it a little bit of a quote-unquote a pleasant experience as you solve these problems. So our solution to this system of equations would be the order pair negative 4 fifths and negative 2 fifths. Okay, here we go. That's our answer. Okay, so the next method of solving for a system of equations that we'll be looking at will be called, it's called the elimination method. This is also one of, I also like to do this one because it just gives you that a little bit of a challenge, I guess you can say, of canceling out temporarily one of the variables. And it's very similar to adding fractions and subtracting fractions, because at one point you're going to have to look for the common multiple, And another thing to keep in mind is that in order for you to cancel or eliminate, quote unquote, for temporarily eliminate a variable, one of them has to be positive, one of them has to be negative. So let me show you what I mean in this case. So for example, for the first system of equations here, I have as example A, I'm trying to eliminate one of the two variables temporarily, right? So in this case, if you look at it, it's x plus y equals 5 and 2x minus y. So can you guess which variable is going to get temporarily eliminated? Okay, if you said the y's, you were correct. So we're going to treat this like an addition. So let's start from the left. 1x plus 2x gives us 3x, and then positive y minus y cancels out, right? That's the one variable that we're quote unquote temporarily canceling out. And then we move on to the numbers, which is 5 plus 4, which gives us 9, correct? Okay, and we solve for the value of x, in this case by dividing by 3 on both sides. So that cancels out. So you're left with x is equal to 3. Now, you found one of the values for the variable x here. Actually, I'm sorry, you found the value for x, or for one of the variables. So you have to plug in this value to one of the two original equations. I wouldn't plug it into this one because you got to multiply 2 times 3 minus y and solve for 4, or solve to see what gives you 4. If you already have a simple equation here that's going to make it a lot easier for you, plug it into that one. So we're going to use the first equation and we're going to substitute the value of x with the 3 that we mathematically solved. So we have x plus y equals 5. And then we said that x is the value of 3. So 3 plus y gives you 5. If you want to do the mental math way, is what number plus 3, right? What number plus 3 gives you 5? It's going to be 2, so y is just equal to 2 here. So the solution, the ordered pair solution to this first set of equations or system of equations, it's 3, 2, right? Again, it has to be an ordered pair. Let me make this look like a 3 because it doesn't look like a 3. Okay, and that is your answer here. Okay, so that was the first example. The second example that we have here, guys, is the following. Here we have 3x plus 6y equals negative 6, and we also have 5 minus 2y equals 14. So remember, we said that we need to temporarily cancel or eliminate one of the variables by having one positive and one negative, which we already have here, the y's, as meeting that criteria. So now we have to eliminate or be able to cancel out that 6, right? And we have a 2 here. So what number do we need to multiply the bottom equation by to give us a 6 in the middle here for the y? It would be by 3. So we multiply the whole equation by 3. So that will give us, I'm just going to recopy the first equation, 3x plus 6y equals negative 6. The second equation is going to be 3 times 5 gives us 15x minus 6y, right? Because we're distributing that 3 times the negative 2y equals 3 times 14. It will give us 42 here. Okay? So now we can go ahead and cancel out the middle term, right? The y's temporarily. So that cancels out and we get 18x is equal to 42 minus 6, right? That gives us 36. So divide by 18, divide by 18, and it gives us x equals to 2. So now we can go ahead and either plug it in into the 3x plus 6y equals negative 6, or we can plug it into the 5x minus 2y equals 14. I would go ahead and plug it into the first one because you're working with smaller numbers. Okay, so let's go ahead and do that. So we have 3 times 2 plus 6 y equals negative 6 here. So we we have 6 plus 6y equals negative 6. We got to move this positive 6 to the opposite side by making it a negative, right? Minus 6 minus 6. So you're left with 6y is equal to negative 12. Divide by 6, divide by 6, and y is equal to negative 2. Okay, so let me back it up a little bit so you can see. So the solution, or the order pair that's the solution for that system of equation, is going to be x is equal to positive 2 and the y is negative 2. Again, put it in the parentheses, right? Because that's the format that we write the order pairs. And that is our answer there, guys. Okay, I'm trying not to leave anything out of the screen here. Okay.